Good day, guys. For my final project, I will walk you through Amazon Quantum Ledger Database. This will be a quick walkthrough through the project. A step-by-step video can be found in part 2. It will be sheer adrenaline, so let's get started. Before starting, we need to understand the structure and terminology of QLDB. The ledger holds the applicable tables. To some extent, you can think of the ledger as a database that holds all the tables together. Within the AWS console in the query editor, there is one querying language and one data interchange format used. The one on the right, Particle, is an open Amazon-developed SQL dialect whose purpose is to interact with both SQL and NoSQL databases. Ion is a data interchange format that is related to JavaScript object notation. These two are important to keep in mind because if you use standard SQL in the query editor to create a table, you may have a bad time. In the bottom half, we need to understand what a journal is. The journal is a record of all the changes made to the tables. We can only append or add to the journal. The set of changes makes up a distinct block, whose block address and ID we can query in the query editor. Remember, the journal is not the table itself, but rather the changes made to the table. Each block is hashed for verification. So if a journal is a record of all the changes made, broken down into blocks, what is a digest? The digest is basically the journal. The only difference is that the digest is hashed using SHA-256. Since the digest is a hashed journal, we'll use it to verify data integrity. You may be thinking, well, I like blocks and I like chains. Why can't we use blockchain instead of QLDB? Although QLDB possesses similarities with blockchain, QLDB is more geared to apps or data that you would want a central authority involved in and whose servers you may not want to manage manually. Think of credits/debits at a bank or tracking who owns which vehicle in a particular state. Blockchain, in contrast, is completely decentralized. This means that no one user has unlimited authority in changing docs, for example. The second one is redundancy. As of the time of this video, QLDB builds the ledger across 3 availability zones in a region. In case an availability zone were to go down, we have 2 others to back it up. In contrast, blockchain could potentially have a given document across every node or computer. Third, as we talked about, QLDB's console primarily deals with Particle and Ion. We'll talk about Python APIs later, but those are the main ones in the console. For blockchain, you have more wiggle room. However, you could potentially lose the transaction speeds that QLDB provides. Fourth, QLDB is designed with security in mind, so it's predominantly private. In contrast, with blockchain, you can have both public and private constructs. For QLDB, this means that we may not necessarily want to open up our bank's transactions to the world because we want to protect customer information. So, with a brief understanding of blockchain and QLDB, here's an overview of a project that I will show you how to do in part 2. In some banks, they will have a lending arm for leased vehicles. This means that banks need to know who has the vehicle and when it changes hands for potentially a new lease. We need to centralize this for 2 reasons. 1, consumer privacy, and 2, to assign a specific department to manage that data. In this project, we'll do 3 things. 1, create the database or tables with Particle. 2, we'll verify the tables, meaning that we want to verify that they're still in the same location and still have integrity. And 3, we'll upload the journal to an S3 bucket to get other parties that particular journal. More specifically, it looks like this. First, we create an S3 bucket to receive our journal. Second, we create a role for users with JavaScript object notation to export those journals to our bucket. Then we will use both QLDB and Boto3, the Python API that we'll use in the client. In QLDB, we'll create 3 tables, pull the changes IDs for verification, and execute the verification. In Boto3, we'll develop a Python code to get the digest or fingerprint for verification. We'll also send the request to QLDB to export the journal to our S3 bucket. Finally, here's a brief summary of the results. In the top half, we first create our tables with Particle and Ion and pull all the metadata to verify the changes. We acquire the digest or fingerprint for verification, either via Boto3's API or via the console. Finally, we plug in the digest and the metadata for our changes and verify the results. In the bottom half, we develop a Python code to request QLDB to automatically send out the journal contents to a bucket of our choosing. Thank you so much for reviewing this. In part 2, we'll do a deep dive on how to do each step.